Hi, welcome guys. This video will discuss about segment routing on demand NextHop low latency service. My name is Hinwato. I'm a Cisco Technical Solution Architect, and this video is part of Cisco segment routing and Cisco NSO demonstration. Okay, now we are focusing on the challenge and constraint number 4, 5, and 6. Please check on the video about Cisco segment routing, automated steering that already explained and addressed the constraint of number 4 and number 5, where the RSVP has the limitation in providing the different SLA path per VPN or per VRF in one PE. While Cisco segment routing automated steering, we can differentiate services for different paths. Now, the current technology also has limitation in the latency. There is no latency awareness and there is no disjointness path differentiation capability either. Let's check our topology here. Red link will be the bandwidth preferred topology, while the green link will be the latency preferred topology. So we have differentiated the metric. So the bandwidth metric based on the IGP cost, and then the latency metric based on the TE metric. At this moment, the TE metric is defined statically per link. So in this testing, when the service is forwarded through the low latency path, it will select the green link as much as possible, while when the bandwidth preferred path, it will select the red link, which is as a bundle, Ethernet, and a higher bandwidth there. So in this testing, we will also use Cisco SR PCE here, which is a router 93. And then we also activate the PSAP, Path Computation Element protocol on the SR PCE and also on the PE 5, 6, 7, and 8. And also we also use BGP link state on the blue line. We activate the BGP link state on SR PCE and on the router 1, 2, 3, and 4. Let's see on the router. First, I'm gonna check. I'm gonna activate the PCE client on the router 5. So I'm gonna use Cisco NSO here on the transport. Check on the router 5. So check on the SR option menu. There's a SR PCE client and to activate it. And then I also need to activate the BGP link state on router 1, which is we'll use the blue line. Router 1, activate the BGP transport technology, which is BGP link state here, BGP enabled, and we will define the BGP peer towards router 93 and then also 94. Here we define the BGP role, BGP link state ls, and also 94 as BGP link state ls. Okay then, I think let's see on the native config. I already configured other routers, so I only configure these two routers and will show the CLI command that we activate router 1 here for the router BGP, and then we activate the address family link state, as well as on the router 5 we activate the PCC client here and we define the PCE server, which is the SR PCE address 93 and 94, and commit. So I have configured other routers for the PCE client and the BGP link state for the sake of time. And then Let's check on the router. Okay, that's good. Let's check on the router. First, let's check on the router 5. Show PCE, show segment routing. This is traffic engineering. TCC, IPv4, here. See, on the router 5, which is the PCEP client, it already has session to the PCE server, which is the SR PCE 93 and 94. The best PCE now is 93. And then let's see on the router 1, show BGP link state. If you want to see what is actually distributed to the SR PCE, this is the information. It looks like the OSPF database, including with the all SR information there. So let's see the neighbor BGP neighbor session. Yes, it's established to the 93 and 94. Now let's check on the SR PCE. 93 is SR PCE. Let's check whether he has all the BGP link state session to the router 1, 2, 3, and 4. So BGP link, and some. Okay, there are 1, 2, 3, and 4, and order also receive the prefix around 193 each. That's good. It means that SRPC already received all the OSPF database link state information throughout the network. Now he has the full visibility of the OSPF and SR database. Now let's see on the PCEP function. Show run PCE. This is the running config for the PCE, and he has the redundancy PCE, which is synchronized with 94, router 94, right? And it also activate for the REST communication here. And let's check the PCE IPv4 here. Okay, this is the session from between PC server or the SR PCE and its client, which is router 5, 6, 7, 8, and also it's a redundant PCE peer. Okay, in the PCE, we can compute the path on behalf the node in the network, such as so. Let's try it. Show PCE IPv4. Yes. Let's say I'm gonna similar to compute the path from router 5 to router 8 based on the bandwidth metric. Source 555, destination 888, here, and metric type IGP. This is the path from router 5 to router 8 based on the IGP cost. The hop is from 1, 3, and 8. 5, 1, 3, and 8. Okay, see? Let's see based on what is the option. There are latency. Okay, for the latency preferred topology from router 5 to router 8, the suggestion, the recommended path is 2, 4, and 8, which is the link, the green link, 2, 4, and 8. This is the response that SRPCE replied to the PCEP client, which is the PE. Now, let's check on the PE. Okay, here we can see that the example VPN is a 5G VPN. There are two services, 5G control and 5G user. So for the 5G control, it prefers the high bandwidth, and then for the 5G user, it prefers the low latency part. So it means the green part. Well, in the previous video, The Cisco semi-routing automated steering shows how to differentiate this part based on the services. Even within the same VRF, one VRF. That's cool for semi-routing. Let's see on the NSO configuration for that. VPN here. Let's see on the 5G. We have activated the SR policy traffic engineering steering here, true. And I have two policy here for router 5 to router 8. And for services 5G control and 5G users. So within this policy, we have defined the hop by hop policy. And let's test on the router 5. Let's do the test route. I'm going to test route to the 8511 and 8521. Trace route VRF 500 to the 5G control is 8511. 5G control, we prefer the blue line 1, 3, and 8, which is a high bandwidth topology. Yes, we have defined this policy on the NSO as well. Let's see that. This is a 5G control. SR policy here with the hop by hop level is 1, 3, and 8. Okay, and then for the 5G user, which is 8521, 5G user 8521, the preferred path is the green link, which is based on low latency preference. Let's do the trace route. Yes, 2, 4, and 8. 2, 4, and 8. And it also determined by the NSO policy here. And move back. Okay, 5G user. 5G user. Okay, this is the adjacent seat we define 4 and 8 through the router 2, 4, and 8. Okay, can you imagine that if we need to configure this policy on each PE to comply with the SLA requirement? Let's take as an example. How many TE policy required? Assume that there are 50 PEs for 5G application across the nation to support the 5G BTS rollout, and each PE to deliver 2 services. So the formula to count the how many TE policy, yeah, it's like this: 2 times 50 times 50 minus 1 and divided by 2. And it's around 2,450 TE policy, because it will make a full mass TE policy from PE to PE. Traffic engineering policy. Well, more PE growing there and more services introduced there, there will be more TE policy number. It will create more complexity. Well, there is a very high risk to have more errors later. Cisco is already create the innovation with the segment routing policy and also low latency awareness with the SR PCE, and we also define it as a segment routing on-demand NextHop, which is SR-ODN. SR-ODN is the automated traffic engineering service, creation, deletion, based on the BGP NextHop presence. In this case, which is a L3 VPN BGP NextHop. When the L3 BGP VPN NextHop is received and present, router will automatically set up the segment routing traffic engineering, and vice versa. When the BGP NextHop disappear, the traffic engineering will also be deleted automatically. Sounds cool, right? Let's see. First, I'm gonna remove all the manual segment routing policy here first, and we will set up the segment routing on-demand NextHop. Let me remove this. Okay. On the router 5, let me go commit. So show segment routing traffic engineering policy. Okay, I still have it, but this is not for 5G, and this is for the auto car. Let me remove it as well. Session, okay. And the auto car, to make sure that there is no SR policy on the router 5. Yep, this one. Okay. Yep, that's it. There is no more segment routing traffic engineering policy on router 5. And also on no, let's check on the router 8. Show sector 4. Nope, there is no on the router 8. On the router 7, show sector 4. There is no either. Okay, let's start to configure the segment routing on demand NextHop to the NSO. On the VPN slice 5G, I'm gonna activate the SR on demand NextHop here too, and it will automatically assign every PE within this VPN or VPN will activate the SR-ODN policy, segment routing on demand NextHop policy. And specifically, I wanna assign that the low latency is for the 5G user. Let's go each PE for each PE. 5G user, I'll have this field low latency. Let's make it as a low latency services here. Yeah, while the 5G control is not the low latency service. Okay, this is for the PE5. Let's do it for the PE7. 2. And then on the PE8, we can make the default as a low latency once he select the 5G user. Yeah, that's only the policy setting. Okay, true. Now, I think let's check on the native config CLI. On the router 5, on the segment routing configuration, we have activated 2 policy. So on-demand color 10 is for the low latency part, and we will consult or we will ask to the PCE here, and as well for the on-demand color 500, this is for the IGP part, and also we consult with the PCE. So the similar configuration is applied for other PE, router 7 and router 8. And commit. Here. The segment routing on demand NextHop will simplify because we simplify the traffic engineering policy because the traffic engineering policy now is created automatically based on the BGP NextHop presence. So it can automatically assign the destination on the traffic engineering for every PE within this VPN or VRF. Let's see on the router. So let's see on the router 5. Okay, as you can see, there are 2 services here for 1 PE destination. For the destination 7, we have color 500 and color 10. And also for destination 8, we have 510. 500 reflect for the IGP base part traffic engineering. And then for the color 10 is for the low latency part. Okay, let's test to trace. 8511 is the 5G control, which is on the blue part. Blue part will use 1, 3, and 8. Yep, that's it. And then for the 5G user, 8521 will follow the green link, which is 5, 2, 4, and 8. Yep, 2, 4, 8. So let's test on the router 7 here, which is I changed to 7. Okay, for the 7511 is the 5G control. I assume it will be go straight the line 1, 3, and 7, right? And then for the 2-1, which is the user, it will go to the below part 2, 4, and 7. Follow the green link right here. As you can see, we don't need to define the semi-routing policy hop by hop label anymore. Now it will the semi-routing will ask for the SR PCE. This is the detail that show segment here for the color 500, which is the IGP part. Destination to the router 7. This is the BGP OnDemand NextHop, and this one is active. And then it will consult to the PCE 93 here, as how to get there. As we continue, this one is for the low latency color for the destination router 8, and this is this is for to consult with the dynamic PCE 93 and define the hop level. So this will give a very much simplification in the traffic engineering policy. As you can see on the router, show around segment routing. Well, the configuration is very simple now. You don't need to define hop by hop, label to label for each policy, for each destination. It's automatically created. And if you see on the show BGP VPN v4, as we can see, there are color related to the BGP NextHop here. See? I hope you can see how beautiful of Cisco semi-routing on-demand NextHop in the traffic engineering simplification. And on top of that, Cisco also innovate how to measure the low latency dynamically and near real time with the MPLS performance monitoring, and between the OSPF or RSVP router, it will send the probe to the neighbor periodically, collect the result, and then include it in the OSPF advertisement, and it will distribute to the rest of the network. And also finally, it will be distributed to the BGP link state, and then end up in the SR PCE. And this will give the real-time low latency service information. Feel free to access this for more information on the www.segmentrouting.net tutorial. And there is also a good video by Jose Liste for the segment routing on demand NextHop demonstration. And these are the recommended book of segment routing part 1 and part 2. Part 2 specifically very good explanation about segment routing traffic engineering and on-demand NextHop, SR PCE. Yeah, already explained very clear there. In summary, we have built our network in the automated way to create the traffic engineering, to fulfill the customer SLA on demand, and then also to simplify our network. So this is the beauty of the Cisco segment routing on demand NextHop for the low latency service. Thank you guys. Thanks for watching.